In this lecture, we are going to learn congruences and its properties. So congruences is nothing but the divisibility. Divisibility and more format. Okay, another language of mathematics. That's congruence. Okay, so congruence definition. Suppose m is a positive integer. Okay, it's a fixed positive integer. And we say that A is congruent to B modulo m if this A minus B is divisible by m. By m. And it is denoted by, and it is denoted by A is equivalent symbol B. In the bracket, we write modulo m. The m is called modulus value. Here m is called, the value of modulus. If A is not congruent to B modulo m, and it is denoted by the following. If A is not congruent to B modulo m, then it is written as A that equivalent not, right? Strike out B modulo m. So the congruence purely, it's nothing but if A minus B is a multiple of m, then we write A congruent to B modulo m. Now we will write in properties of congruences by using the properties of division. Because congruence is another way of writing division. That's why we are going to write the congruence properties based on the division properties. Division properties, congruence properties, division congruence properties, division properties. Division type. Okay, another way of writing a division is the congruence. Congruence properties in the first property in this set of properties, m is positive fixed number, m is positive, a, b, c, or d are integers. The first property is A is congruent to A modulo m, always. The reason is that m divides 0 always. M is positive number, it divides 0, and 0 is written as A minus A. So m divides A minus A. So the A congruent to A, so the relation, congruence relation is reflexive, right? So the congruence relation is reflexive. Is reflexive. So congruence is a relation between AB. AB kadala relation than the congruence. So it's a relation between AB. Congruence is a relation. So note, the congruence is a relation between congruence. It's a relation between two integers. Two integers. The second property is that if A congruent to B modulo m, then we can write B is congruent to A modulo M. Okay, so this property based on the following property of division. Suppose M divides A minus B, then M divides negative of A minus B. So M divides minus of A minus B. Okay, which means what? M divides this minus 1 is multiplied with the within the bracket. So we have B minus E. Okay, this is even on other way also. Therefore, if A is congruent to B, then B is congruent to E. This, from this we write that the congruence relation is symmetric. A congruent to B, B congruent to A, ரெண்டும் ஒன்று தான். அதனால எப்போ நம்ம என்ன எழுதலாம், சிமெட்ரிக் ப்ராப்பர்ட்டிலேருந்து என்ன எழுதலாம்னா, A is congruent to B or B is congruent to A அப்படின்னு எழுத தேவையில்லை. A and B are congruentனு எழுதிக்கலாம். A and B are congruent modulo M அப்படின்னு கூட எழுத முடியும். Because of the symmetric property, congruent modulo M அப்படின்னு எழுதலாம். Because A congruent to B என்ன எழுதினாலும் B congruent to A என்ன எழுதினாலும் ஒன்று தான். அதனால you can write this statement also for the congruence. Right? And the third one is if A congruent to B modulo M and B congruent to C modulo M, then you can prove that A congruent to C modulo M. Right? So proof of 3 is the following. A congruent to B modulo M. M divides A minus B. Right? B congruent to C modulo M. The definition படி என்ன, M divides B minus C. இப்போ ரெண்டு நம்பரை M வந்து ரெண்டு நம்பரை டிவைட் பண்ணும்போது அதோட அடிஷனையும் டிவைட் பண்ணும் இல்லையா? அதனால M divides A minus B product addition B minus C அப்படின்னு எழுதலாம். ஸோ இங்கே minus B plus B cancelled. We have A divides, sorry, M divides A minus C. So this is written as A congruent to C modulo M. So the relation is congruence, transitive. So the relation, congruence relation is transitive. So the congruence relation is always equivalent. So if a relation is reflexive, symmetric, and transitive, the relation, congruence relation is equivalent. Equivalent on the set of integers, right? It's a equivalence relation on the set of, okay, on the set of integers, that is a set. So one can partition Z based on the equivalence relation. Right? So it's a follow. Z can be partitioned into equivalence classes. And then the equivalence classes எப்படி இருக்கும் அப்படின்னு பார்ப்போம். அது அந்த equivalence classes எப்படி பிரிக்கிறோம் அப்படின்னு பார்க்கறதுக்கு முன்னாடி some more properties பார்க்கலாம். Fourth property, A is congruent to B modulo M, right? Is okay, it is written as B congruent to A modulo M. That is what symmetric property, and this is same as A minus B congruent to 0 modulo M. Okay, the first one is proved in symmetric property. So first one is symmetric. This is symmetric property. Okay, so in this property we have to prove that if A congruent to B, A minus B congruent to 0. That property is proved using only the definition. Right? So A congruent to B modulo M, if and only if M divides A minus B. Okay, that A minus B is rewritten as A minus B, I write minus 0. So in the place of B, we have 0. In the place of A, I have A minus B. So again, by the definition of congruence, A minus B congruent to 0 modulo M. Right? As a consequence of this property, M divides A if and only if A is congruent to 0 modulo M. So if a number is multiple of M, it is congruent to 0. That's the property. Right? Definition 6 property, if A congruent to B modulo M and C congruent to D modulo M, then so one can add the congruence. A plus C congruent to B plus D modulo M. That is the addition of the congruences. And you can multiply the congruences. AC congruent to BD modulo M. As in the equations, you can multiply, add the congruence relation. Okay. So proof is very simple. Okay, just by using definition and properties of division. So first data given is A congruent to B modulo M, which means that M divides A minus B. ரெண்டாவது கொடுத்திருக்கிறது C congruent to D modulo M. அதில் definition யூஸ் பண்ணா M divides C minus D எழுதிக்கலாம். Right? So M divides both A minus B and C minus D. So M divides addition of this A minus B plus C minus D. So on the right hand side dividend is rearranged as A plus C minus B plus D. So now we use the definition of congruences, that A plus B, A plus C, right? A plus C congruent to B plus D modulo M. So this is the first part, right? For the second part, we use some tricky things. What we have to prove is the following. Okay, so we will roughly use that. We want to prove that AC, okay, this AC congruent to BD modulo M. That is we want to prove. So the proof பண்றதுக்கு பதிலா என்ன சொல்லலாம், M divides AC minus BD அப்படின்னு. ஓகே, இப்போ AC மல்டிப்ளிகேஷன் வேணும், BD மல்டிப்ளிகேஷன் வேணும். இப்போ இந்த M divides AB, M divides A minus B, M divides A minus B, and M divides C minus D. இதுல AC இந்த பக்கம் BD வேணும். அப்போ என்ன பண்ண போறோம்னா, first A minus B will be multiplied with A and C minus D will be multiplied with B. Multiply பண்ணா என்ன ஆகும், the linear combination எழுதுறேன். Right? C times A minus B plus B times C minus D. Okay, ஏன்னா A minus B, C minus D M divide பண்ணும்போது அதோட linear combination divide பண்ணும். So இதுல இருந்து என்ன எழுதிக்கிறோம்னா M divides AC minus BC plus BC minus BD. So minus BC plus BC cancelled, which implies M divides AC minus BD. So congruence relation AC congruent to BD modulo M. So the property the two congruences can be added, and you can multiply. You can also multiply the congruences. So in the property in addition, if A congruent to B modulo M, then for any integer. So first one is for then first one for any integer C, AC congruent to BC modulo M. Right? The second one for any positive integer K, AK congruent to BK modulo M. So you can multiply C on both sides, okay, without any difficulty. And also you can raise the powers of AB. If AB congruent to AB are congruent, then AK, BK are congruent. And the sixth one, if A congruent to B modulo M, then for any integer C, AC is congruent to BC modulo MC. Okay. So you can multiply C throughout the relation with A, B, and M. So proof is very simple, and proof A congruent to B modulo M means M divides A minus B. Then with both the divisor and the dividend, you can multiply C, A minus B into C. This is a division property. So here MC divides AC minus BC. Okay, again use the definition of congruence, then AC congruent to BC modulo MC. And also one can cancel the C through from the relation if C is non-zero. So that is the next property. Sixth property, seventh property. Okay, if C is non-zero and A congruent to B modulo C. AC, right? AC congruent to BC modulo MC, then that non-zero number can be cancelled from the relation A, C and BC, and also from the modulus value. Then A congruent to B modulo M. So we can cancel non-zero number throughout from the relation. And the eighth property, if here also one can, that's if A congruent to B modulo M and B is a positive number which divides M. Okay, comma D positive and D divides M. Then the modulus M can be replaced by D. Okay, this property followed from the transitive properties of property of divisibility. So proof. Okay, we know D divides M. A congruent to B modulo M. So gives that by the definition M divides A minus B. So now we use the transitive property of division. D divides M, M divides A minus B, which implies D divides A minus B. So again, by the definition of congruence, A congruent to B modulo D. So that modulus value can be replaced by its divisors. That is a property. So this property, this says that the value of modulus, value of M can be replaced by its positive divisor in the congruence relation. This is property number 8. Then property number 9, that if suppose AX congruent to B AY modulo M, if and only if X congruent to Y modulo M by GCD of A comma M. Okay. So proof. So in this proof, we will use the properties of divisibility. Okay. So we recall the following, then we will use that. Okay. What are things we have to suppose? Let us take if B is the GCD of AM, then A by D comma M by D are relatively prime. That is we know. Okay, if all the common positive divisors are removed from A and B, then the rest of the numbers have no common factor except 1. Second thing, if A divides BC and A, B are relatively prime, then the number A divides C. Okay, the product or A divide பண்ணும்போது the productல எந்தெந்த number relatively prime அதை remove பண்ணிடலாம். Still that division valid. Right? இந்த ரெண்டும் நம்ம யூஸ் பண்ணுவோம். Proof. So proof of 9. Property 9. Okay, so first we assume that AX congruent to AY modulo M. So before that, let us take D equal to the GCD of AM. Then, so from this, we just use the definition of congruence. M divides AX minus AY. Okay, it implies M divides A times X minus Y. Okay. So again, use the definition of division. So there is a integer Z such that Ax minus Y equal to MZ. Okay, so M by D is the number, A by D is a number which is division conjugate of D. A by D times D equal to A, we know. B by D, M by D, because M is divisible by D. So we write this. D equal to M. So in the place of A and M, we write A by D, D, M by D into D. So this is A is written as A by D times D, X minus Y, M over D times T Z. D is a positive, D is the GCD and it is positive. So you can cancel the number D. Then we will arrive at this point. A by D, X minus Y equal to M by D into Z. Okay. So here this M by D divides A over D into X minus Y, because this A over D X minus Y is multiple of M by D. Right? Since M by D comma A by D, so you have GCD 1. So this M by D divides X minus Y. So again use the congruence definition. So by the definition of congruence, X congruent to Y modulo M by D. Here where D is A, GCD of A and M. So X congruent to Y modulo M over A comma M. That's a GCD. Okay, this is so one part is proved. Now we will prove the converse part. The converse part is conversely, assume that X congruent to Y modulo M over D. We know that D is the GCD of A. Okay. Here if we multiply A throughout the equation, so we have AX congruent to AY modulo AM by D. Right? Here the modulus value is AM by D. D is a common divisor of AM. D divides both A and M. So further AX is written as AX congruent to AY. So modulo A by D times M something. Right? Here M divides A by D into M. Right? So the modulus value can be replaced by the divisor, positive divisor. So in this place, M divides this number, modulus value. So AX congruent to AY modulo this whole number A by D into M is replaced by M because M divides this number. So this is a proof. Okay. M by, therefore, we have proved that AX congruent to AY modulo M if and only if X congruent to Y, X congruent to Y modulo M by A comma M. Right? So as a corollary of this 9th property, we write 10th property if AM is AM are relatively prime and AX congruent to AY modulo M. Then by the previous property, we can write X congruent to Y modulo M over A comma M. Here A comma M is 1. So X congruent to X congruent to Y modulo M over A comma M. A comma M is GCD is 1. So this is modulus. So this property is called cancellation law. This property is cancellation law. So it is called cancellation law. We have cancelled a number from the relation A congruent to AX congruent to AY. So in order to cancel a number, it must be relatively prime to M. Okay. So if you want to cancel a number A from both sides of the congruence, the number must be relatively prime to 1. So that is the important property. Right. So with this, we will stop this lecture.